part, in this part of the course, we are going to continue with the remove method. The remove method will help us to remove method from the list. So let's go to the drawing board and try to illustrate it. Assuming we have a couple of nodes in our list, 3 nodes. So this man points to null. So let's say we have 30, 20, and 10. So this is the next sphere, the points to the next node. And this is our list. And we wish to remove 20. How do we do it? To remove 20, we just need to remove this pointer from here to here. And then the linked list, we have just 2 items, 10 and 20 and 30. So 20 will be out of the list, and the pointer for the node 10 will point directly to 30. And when we look through this list, we are just going to have 10 and 30 on our list. So let's do an illustration in the code and we're done. So the first thing is to create the method called remove. It's a public method, remove, and remove takes in a parameter called an integer parameter, and this will be the index of the item we wish to remove. So for example, if we want to remove 20, it will be 1. So first item is index 0, second is index 1, third is index 2. So you pass in the index which we wish to remove. The next thing is to check if the list is empty. Remove returns void. So check if the list is empty is the first thing we do. So if the list is not empty, before we can remove. If the list is not empty, then we can go right away to remove. To remove an item, the first thing to do is to create 2 nodes. So this is what we are going to do to remove this item. So this is our head. It points to this node. Now to remove this item, we need to keep track of the previous item. So we need to loop to the end of this item. We need to loop to this item and then get the address of the previous node to point to the next item. So this is what we're going to do. We're going to create 2 pointer, the current that will point to the same location as the head, and we print the previous that will point to null initially. So it will point to null. So we check if the item has a value and it is not in the index which we wish to remove. So our index in this case will be 2, will be 1. So if this item has an xv and the index is not 1, we move current to this next item and we move previous to current, the previous current. So this item. We check again if this item is what we wish, it has an xv and also is not what we wish to remove, is not in the index. We do the same, we go to the next item and we put current to the next item and previous will point to this item. So but in this case, the item which we wish to remove is at current. So we now take previous to point to the address of current, which is the next item. Let's illustrate it in the code, and I'm hoping it will make it clear why we are coding. So the first thing is we check if the item is empty. Another thing is we create the current node to point to the head, and we create another node previous to point to null. So previous initially points to nothing. There's no other items before the head, so previous is not. And now we check in our while loop why the current item dot next is not equals to null, means it has an item, and the current node so we do this, we'll create an integer called count node to keep track of where we are. So an count node is not equals to index. So index is the item which we wish to remove. So why the current dot item, so the next item is not null, the next field of current is not null, and where we are is not equals to what we wish to remove. Then we now put current, we put previous to be equal to current. So previous will be current, and current will be current dot next. So current will be to the next item. So that's what I'm saying. Why this item is not what we wish to remove. Current we go to this next item. Current we point to this next item. Let me get a different ink to illustrate this. Why this item is not what we wish to remove. Current we go to the next item, and previous we point to current. That's what we are saying. But if it's what we wish to remove, the loop is gonna end, and we are just gonna take previous dot next to be equals to current dot next, and we reduce the size minus minus, so the size will be reduced. So if the item is what we wish to remove, we have, if this item is what we wish to remove, then our current, our previous, sorry, dot next, this previous, the next fee of previous, we point to current dot next. So this next fee of previous, we point to the next current dot next, the next one. That's what we are doing. And then we now remove current to be equals to, we now reduce the size, sorry, the size as -1. That's what we do. And also we need to keep track of our node by increasing it in each count. So I hope it is clear. If it's not clear, you can leave a comment below and I will try to explain and make a clearer video. So basically that's how we do to remove an item in the node of a particular index. So let's test. I hope there's no error. Let's try to remove this second item. So if we remove the second item, we do my linked list, start remove. Second item has index 1. After removing, let's print the size and see the number of elements that's there. So initially it prints the list is empty, true. Put 3 items, print the size is 3, remove the middle one, and print the size is 2. Now let's write another method to print out all the contents of the linked list. I'll put it right here. Public string, the method will be string. We give it a name like toString, print string, call it print list. Let's call it print list. Initially, we'll have a string, we'll call it out, will be equals to empty string, and then we'll create our node current equals to this dot head. So our current will point to the head, and then we'll create y current dot next. By current dot next not equals to null, we just simply attend out plus equals to, give a space, plus equals to current dot value. So at the end we can return out. We can also make it cool by putting some cool stuff at the end. So that's our list. What is happening here? Let's explain. Make a new discard. Now what are we saying? We have some nodes and we wish to print the content of each of these nodes. So we go y current is pointing to the head, so this is current. Y current dot the next fee is not null, we print the value. So here we'll print this value, and then current will be equals to current dot next. So yeah, we have to add that. Yeah, current equals to current dot next. Good. So current will be equals to current dot next. So current will point here, and we check is the next sphere is not empty. Current dot next is not empty. It prints out this value, and current we point current dot next, which is here. It checks the next sphere is empty, and we just print current. Oh, so it has to check if the field is empty. So we have to remove next here. We have to remove next and print just current. So current is ahead. We check. Why current is not empty means current is pointing to the head. The head is not empty. We'll print the next sphere, and we check. Current is pointing to the next now, and it checks the next is not empty. Current is not empty. It has some value. We print this sphere, and current will be equals to this man, and this man is not empty. We print this sphere, and current will be equals to this man, which is empty, and the next time in the loop we will check current is empty and we go out of the loop. So it's the same thing we are saying. Initially current is the head, and then we check current is not empty, I mean the current has a value. We print the current, and we move current to point to the next node, and whenever current is null it will come out of the loop, and we print out what we have. So let's run it now. I hope everything should work if we are testing the print list. So let's try to put 3 items in the list, and we print it out, and we remove 1 item and print it out. Sys out. So we sys out my linked list dot print list. So yeah, we'll print out the first 3 items. We'll print the size. We'll remove 1 item. We'll print the item, and then we'll print the size again. So run. So the first thing it does is to print true, means the list is empty, and then put 3 items. Print the items 10, 20, 30. These are the 3 items printed here. Print the size is 3. Remove item at index 1, which is 20, and then print the list. So 20 is no longer in the list, and then you print the size 2. So that's how we add linked lists, add and remove items from a linked list. And basically that's all about linked lists. We can add an item, we can remove an item, we can print the linked list, and you can do pretty good stuff. So thank you. If you have any question in this video, please leave it in the comment section below, and I might do another video to clarify it if you cannot understand or if you did not understand. And please don't forget to like my YouTube channel. I'm still new to this channel, and I'm hoping to have encouragement from you guys. So please like and subscribe to my channel. Thank you. Bye bye.